Kaplay recently added some new AI features. AI in terms of game AI and not LLM-like things. Game AI is really like what a game object that's not under player control should do during the game. For example, an enemy, should it move, should it attack you, stuff like that. And I crafted a little game where you need to defeat your opponent, and your opponent is using something called the rule system. Alright then, here we go. Before we dive in, ReScript 12 was officially released. Let's just quickly go over the blog post. I'm not gonna make a separate what's new in ReScript 12 video. I feel like the blog post covers it, and I don't know, I've just been using ReScript 12 throughout most of my videos. There's a new build system, which, cleans up a lot of things behind the scenes, but is also just better in supporting mono repositories, mono packages, and all that stuff. There's like an entire blog post also dedicated to how the new build system works. It's a thing in Rust. This is a very in-depth, detailed post. If you're interested in that kind of stuff, just definitely check that out. There is a new standard library, although I've always used that standard library. Some nice things about operators, dict literals, so the dict syntax, that's actually new. Came across this in an earlier video, so like I mentioned, we've been using all these things and they're all very wonderful. Nested records is a nice addition. Variant spreads, I don't think I have used that, but it's also very interesting that it's there. JSX preserve mode, that's kind of what your boy did here, so I'm gonna pat myself on the back. Function level directives, we use those in Waku, so when we do some React server components, regex literals, there's new regex syntax that's closer to JavaScript, which is good because what ReScript's trying to do is just to be closer to JavaScript. The experimental let question mark, so I had an entire video on that. I'll link that in the description. There's some breaking changes, and yeah, it's all goodness. Try it out. There was a retreat this year. Your boy was present. These are like a wonderful bunch of people, and yeah, happy hacking. Okay, for today's video, this is the little game that I made. I'm gonna play again. I'm the yellow guy down below. The enemy AI is actually following me and firing, so I'm trying to attack it. And there we go, hit it. It is actually, so when I go and move to the left, it will also move to the left. It only fires when it's right in front of me. And when you beat it to death, then you win. So that's the little game. When we go to the Kaplay website, we notice there's a new AI page, like in the guides. And again, AI in terms of game AI. There is a state machine that was already there, the state component. This is like a finite state machine where you move between different states, and based on if you enter or are inside that state, you do specific logic. But then the new thing, and this is what the video is going to be about, is the rule system. So the way the enemy reacted to my presence was actually happening via a rule system. Inside of a rule, you can assert or retract facts. Facts are something that happens in the game world, and they can happen with a certain grade. Like they can be binary, something happened yes or no, but it could also be something in the middle. Like the player is near, like what is near? If it's very near, then the value would be 1, but if it's actually far away, then it might be like 0.20 or anything. So in essence, we can create a rule system, we can assert, retract facts, we can do a lot of other things that are not in this example, and then afterwards we can like give me the grade for a certain fact. If you ask for a grade for a fact, even if it's not there, you're gonna get 0, and then based on what the outcome of the rule engine is, you make some decisions to make the enemy move or attack or hunt or patrol, and that's what this example is built on. So when we look at the code, we have a Pokemon game object. So we have a type T, and then we include all the things we're interested in to like compose all the components, and we have some custom state. Notice that I'm using actually a lot of unboxed for, booleans. Like I don't really need boolean logic, but I do need to keep track of, is the player facing up or facing down, or can it move or can it not move? These are binary questions, but I don't really need like the binary value, and I can use this kind of type, which at runtime will be just a yes or no bool, but at compile time, these are like their own things. When you ask for like a mobility, you can't pass in a facing, because these are like different types. So that's a good thing. Have a make function where I wire up the game object. I add all the components, and that's it. I add some event listeners, so when it gets hit, then we're just gonna do a little hurt animation, so it's like a little fade shiver. When its game object dies, then we just go and see to like either you killed the enemy or you've died yourself. And then basically we go to the game over screen with the context go. And so in essence, we don't really have any logic that controls how to move around with this. We do this in the player module. So when we do the player module, we basically give an ID and a level. So the ID will determine what kind of sprites we're using in the Pokemon. We create the game object and then we like add an update method for the player. So if the player presses certain keys, like did it press up or down or left, etc. We are casting Thundershock. So this is hard coded, but imagine that we have different keys bound to different attacks for the kind of Pokemon. So there's like a lot of flexibility to this. But so far I only implemented a couple of things. We're gonna cast Thundershock, which is an attack, very custom, and we are only gonna allow movement when you are able to move and you pressed it. You are not able to move when you cast an attack, and that adds some certain tension. Like if you can attack, you're vulnerable to other attacks. So it's a little bit of a dynamic there. But now the main thing is we created a rule system for our enemy AI. So a rule system is something from the Kaplay library. You just instantiate it via the make function. So there are bindings for this, which just calls a constructor. Then the first thing we're gonna do is we're gonna add a state. So there's like a rule engine can have a state. This is a custom object according to your own choosing. In this case, I was interested in where's the enemy, where's the player. Are there any player attacks? We'll query those on each updates function. Is the enemy planning on doing horizontal movements? That's something a little bit more for the outcome. Last attack is a little bit of a cooldown mechanism, so I haven't really implemented any of that, but you get the idea. Then there are a bunch of facts where we have custom modules to like add a certain set of rules. The base facts are just like something you can always determine without any prior knowledge of any other rules. Then derived facts are building on the base fact, and then we have like two separate modules. Should we do like defensive rules and should we go on the offensive and try some attack? And that basically is a composition of our rule system. So when we go and see if our update function, so basically we wire up the update function in the Pokemon on update. So for the enemy, this is going to be its update function, where the player had here an update function. Same principle. We're doing some partial application. So basically the update function takes a unit. We're just gonna like pass that to make the callback thing work. But in essence, the three dots represent the extra unit that's coming in here, and that's to play ball with the type of Kaplay, how it expects the callback to be passed into the on update. The first thing we do is we're gonna start with a blank slate. We reset everything in our rule system. Then we're gonna query for player attacks. Player attack is gonna be a Kaplay context querying for everything that has the tag attack and the tag player. So these are just both strings. We're looking for all game objects that match that. In essence, we're just querying for everything that matches, but we don't exactly know which kind of attacks, nor is it really relevant. The player could be attacked by anything, so there's a bit of an abstraction going in a custom component. So this custom component is over here defined in attack. I won't really go over it in too much detail, but in essence, we have like some custom component with some state. And the thing is that you can have a get world rect, which is like a rectangle in world coordinates. Where is the attack? And regardless of what kind of attack it is, all these need to return something. Like if it's a physical attack, maybe the Pokemon itself is going to bump into another Pokemon. So the rectangle could be coordinates from the Pokemon, or if it's something if it's something more projectile based, then it could just be like the fireball, and the world coordinates are the ones from the fireball. Long story short, I just have like a custom component to abstract all this. And when I want to do a query function, I need to define a certain type, but I can't really pick a concrete attack type for my game object. So that's why there's a unit module in attack. It has like an abstract class T. It uses a couple of components, but you're never going to instantiate it. It's used for querying only. And here, when we get a raw game object, we're basically going to call the has function. And at runtime, that's going to check if the game object has our component. We use tag here, and that's, just the attack string over here. So this is also used as the ID of our custom component over here, and that's a little bit how that works Kaplay wise. But in essence, what we get back is a bunch of game objects that are having the attack components, the custom components, and they will have other things, but we don't really know what else they have, and nor do we really care. It's really an abstraction over all the attacks that we have, and if I later add more attacks to the game, it shouldn't affect the enemy AI. So in our rule engine, we set the state to the player attacks. State is really going to be like a mutable thing. So whether the player and the enemy are just references, but then the player attack and horizontal movement, this is going to be more of a vector, and this is just going to be the attacks. Last attack is not used. We're going to execute our rule engine. So we wired up a bunch of rules from these modules. These are custom modules defined above. And when we have a state of our rule system, we can say like, okay, either we check our own custom state, is horizontal movement, defined. If it's not, do nothing, or else, move left, move right. That's internally going to call move, which is defined from the position and the Pokemon, again, Kaplay goodness. And then, the enemy moves left and right to dodge attacks. Okay, and then we're going to check for should attack. So if that fact give us the grade for it. And if the, grade is present, so we're just checking, is it larger than 0? Then we're just going to cast Ember, which is another move. And that's like the fireball you saw. When we go to our base rules, we can see that there are a couple of things defined. So every of these modules has a salience. What is a salience? That determines the order these things are going to be executed. So I first have base facts salience 0, then the next is 10, then the next is 20. I mean, it's just a number, but you can understand that base facts need to run before the derived facts. So that's where they're all having that same salience. Then there are a bunch of facts that we're interested in, like on an X position, is there anything in center, on the left, on the right? How much space do we ourselves have? Like, can we even move to the left? Even if there's an attack from the right, we're stuck if we're not able to move on the left. At a certain point you hit a wall. Then we also just want to know, is the player on the left, is the player on the right? And in this add rules callback, I'm just wiring everything up. So here I call the add rule executing action. This takes a predicate, so it should not even check if there's no player attacks. Like, none of this is relevant. If there are no player attacks, then we're just going to check for certain grades. These all have the ref because they're mutable. In essence, we're just looping over all the player attacks. There could be multiple. And, we're just going to pick the grade that was the highest. And that's why we're just going to update that if necessary. Now we, do some logic. For example, if an attack is on the left and, if the attack found on the left is higher than the last attack that might have been on the left, we're going to replace that. And then eventually, if all these things have like a grade, we're going to assert a fact, and then it's part of our internal map inside of the rule system. And, all these things can then be executed, and we have our first set of rules. So we have another space available. You always want to run that rule. And then we're just going to check like how much space on the left do we have. And that's really just like where are we? Anchor of the Pokemon is like centered. So we just need to add half its size based on the X and the Y. And this is just a little bit of a logic. You get what we're doing here. Then the player position, where is the player? We're going to check, and we're doing a check with a little bit of threshold. Then derived facts. Basically, you can, while you're doing this add rule execute engine, you can also ask for facts that already happened. So in this case, we are going to ask for the center, the left and the right attack. And then we're going to see if any of those was present. That's part of our predicate, really. If any of those were present, then we are going to see, we're grabbing the same values over here, and then we're going to calculate what's the threat on the left or on the right. And that's just going to be a combination of the left attack and the center attack, and then we're just going to assert a new fact. The interesting thing is that we can add multiple rules, but then the more composed rules we add over here, the simpler the next rule becomes. Because when we then go to the next round of rules, the salience is going to be 20. Then we are going to basically ask for what's the threat on the left and how much space on the left do I have, and just make a little bit of a decision over there, okay, we're going to prefer to dodge in a certain direction. And then we have a preferred dodge direction. So these are another bunch of facts. And then we're going to basically read those as well, and then see, if we do prefer, if something came out of that, and then we're gonna check if we already had a direction we're dodging in. So you need to remember this runs on every update frame, so you might already detect that you want to dodge to the left, and then the next frame you're still gonna have that direction, and then you have a final direction. I mean, it's code really, but in essence, then we're just gonna put in the horizontal movement. We're gonna have a final direction on that. And then a little bit later on, we're gonna like see, did that direction change? So in the update, we're just gonna check that movement over here and then do our actual move from the Pokemon. And then like a similar thing for the attack, should attack facts, that's a fact that's gonna be taking into account, are we even in front of the Pokemon, yes or no? And you know, based on that, it's going to like cast the Ember. Okay, so a lot of this logic can really get out of hand. And how do you know over time when adding more rules then that the old rules are still working? So this screams to me like I need some regression testing, and I'm going to show you how I did that with Vitest. This is like a wonderful thing. You can do this Vitest browser thing with Playwright, and then it's going to like launch a real browser, run Kaplay in like a sandbox mode, but it's going to be able to like execute some tests. So I have a little bit of setup over here where we need to put in some browser stuff. Don't worry, you can run this headless. We're gonna run it when we actually want to see the browser, but you could also just like run this during CI and over time still know if your engine is still making sense or not. I added, so these are Vitest test cases. I added a bit of a, helper function with Kaplay context, which is going to like launch a new Kaplay game. It's going to take in an array of strings, and the strings represent what should happen in each level. So we have like empty spaces. This is where the enemy should be spawned. This is where an attack should be spawned. This is where our player should be spawned. And then basically because the attack is dead ahead of our enemy, we're expecting it to have some horizontal movement. So in this case, it can go in both directions and it needs to pick one. And I think our logic says it should be on the right. And then we can just do like some simple testing, which we'll see in a moment in Vitest. And that's how we know that all this keeps working. The reason we do want to do these tests in a browser is because, well, mocking Kaplay isn't that easy. Kaplay just really, launches and attaches to the canvas and uses that rendering engine, and it's not really, easily swappable or mockable or testable. A lot of things like vectors are created from the Kaplay context. It's a little bit tangled, but then again, I feel like I found a good compromise in dealing with this. And in essence, we're going to create an actual Kaplay context. So we are testing the real thing on screen and canvas. We're giving it a height and a width. This should probably be, coming from the playing field, these dimensions. We're going to load some assets, and basically we can return a promise from a Kaplay test. So we're just going to make an artificial promise. We're going to reject when, the input is wrong. So just that we capture all these things in the same thing. Like if you didn't pass any playing fields, then we can't really do a test, etc. Then we are going to hook into the on error. If something happened inside of Kaplay, which we didn't expect, then we want our test to fail. So we're going to reject with whatever error Kaplay gave us. On load, we are going to go over the playing field. We're going to go over all the dimensions. We're going to see, this tile, it's a P. So we need to make a Pokemon. We need to pass in player. We pass an opponent for E. Opponent, enemy, I'm not really using them very consistently. Then we're going to do attack. I made a generic move. So this is another module that has that attack custom component. And I'm simulating a player attack that's in a fixed world coordinate. Then we query for the enemies. We expect one enemy to be there. So yeah, I don't really capture this over here, but I'm just querying it later on. Save for the player, and then we make the rule system where we pass in the enemy and the player. We use unsave over here because we already checked that there was only one. Then we're going to call our test function. The test function resolves a promise. Then we pass in our promise resolve that we're making. We are going to catch if something goes wrong. So in case of an expect, if that goes wrong, it throws an exception, which we catch here, and then reject our outer promise if you want. And there's a finally block. And let's take a look at the browser, how that really works. So I can run bun Vitest. And you can see it launched some sort of UI dashboard kind of thing where we see all our tests. We can run the current test. These all happen very instant, and it happens against the real browser where the game is actually going to run. So I'm pretty confident that, this works. That being said, these are only testing a subset of the functionality. So having all green tests does not equal a great game or anything, but I found it very exciting to see this, in action and have a way to have regression testing. And it keeps LLMs at bay into, accepting what is possible and what's not. And it's, it's a great way to go forward with further development. Thanks for watching. I learned a lot about game development these past weeks. YouTube is full of videos on the topic, but I don't feel like a lot of them are relevant to what I'm trying to do. So if anyone has any resources, be it videos, books, or whatever, that they can recommend on game development, which are more engine agnostic and more, coding wise, how would you approach things, then please leave a comment on this video. Very much appreciated. And again, as I mentioned, thanks for watching. Until we meet again.